Okay, so this time I'm going to explain how I did the redo quiz. Bear in mind this is I discussed some parts of it with my friends, so there will be some parts that will be the same because I discussed it together with my friends. So this is the given diagram, and we are asked about the molar flow rate and molar composition of each streams and the temperature of streams, conversion of methanol per pass and total, and the rate of heat that should be absorbed by the cooling system, the heat released through the waste WHP, and also the rate of steam produced in WHP. So I started off by drawing the diagrams here, and as you can see I add a little an additional stream here, which is stream 11, which this is going to be useful for later on. Then write down all the details, and then the equation, the reaction, and started off with the stream 4. So in here we can see stream 4 is located in here, and we can see that stream 4 equals to stream 2 plus stream 3, which is true because stream 4 is here and stream 3 is here and stream 2 is here. So it is an addition of 2 and 3 here, which in stream 2 we have 100 mol plus stream 3, which is 20 mol, which equals to 120 mol. And then we also have it's going into the reactor, right? So we have CH3OH in the reactor is equals to CH3OH in stream 1, COH in stream 1 minus CH3OH in stream 1 minus CH3OH in stream 7 here. So we have in total the in the beginning it's 20, and then in the end it's 1. So in the reactor here we subtract it, we have 19 moles, and then from this equation reaction I did the what do you call the beginning and then the reacted and then the final result thingy. Then this is what I come up with. So we have N2 plus CH3OH plus half O2, which will be CH2O plus H2O plus N2. So we have 79, and then it will at the end it will stay the same as 79. And CH3OH at first is 20, and the reacted one the reacted is 19, and which leaves us with 1, and half O2 we have 21, and then reacted is 9.5, and we subtract that, we have 11.5, and then these ones they stay the same. So the total we have 129.5 CH3OH moles in stream 5. So you can see here stream 5. So this is the one, it goes here and then it will go here, right? Then in stream 7. Okay, moving on. And since stream 5 is also the same as stream 6, stream 5 here and stream 6 here, so this is like lanjutannya, so it stays the same. So we can summarize that, we can say that stream 5 is equals to stream 6. Now moving on to stream 7. So stream 7 here, we're given the data. There's CH3OH and there's CH2O, and also there's and there's also H2O, which I wrote down here. And from the previous thing that we did, CH3OH we have 1, CH2O we have 19, and H2O we have 19. So we add them up, we have 39. So moving on to the next page here. Okay, so in stream 7 there's H2O, right? And the H2O, it says it is 35%. Let's recall. Yeah, 35% here. Okay, so let us check it first. So we have 19 and over the total, which is 39, as we previously count, right, the total moles. And after I check, it is 48.7%, and this is not the same as the 35% here. So since it is wrong, we are given the 35%. We recalculate it for the total moles in stream 7. So I'll divide this 35% equals to 19 over the total mole in stream 7, and we do algebra as usual. Total 7 here equals to 19 divided by 35%, which I got 54.28 for the result. And bear in mind, this is there's the additional H2O, and then we can check H2O, how much of it is by this 54.28 minus the 39 that we got here, which is 15.28 moles, and this answers the stream 10, which is located here, H2O. Then moving on to stream moving on to stream 8. In stream 8 we only have O2 and N2 here, the flue gas, O2 and N2. So O2 and N2 here, and by using the previous, this one here, I'm sorry, I'm kinda flu. Using the previous one here, we can write down 11.5 plus 79, which is 19.5 moles. And from the given data from the problem, the ratio of stream 8 to stream 9 is 2 to 1. Again, I'm sorry, I'm having flu. Okay, so in stream 8 we can write from the known data that we got, we can write down stream 8 equals to 1/3 of the stream 8. And since stream 8 we got 19.5, we calculated and we got 30.17 moles. And the same goes for stream 9, which is 90.5 minus 30.17. 30.17 is from here, and 19.5 is from it's not focused, wait, okay, 19.7, now 19.5 is from this one here. Then we got 60.33. Then let's check it again. So the O2 in stream 9 is 2 per 3 times 11.5, which is 7.67. And then the N2 in stream 9, 2/3 of 79, which is 52.67. And if I add those up, it becomes around 60.34 something else, and I write it down 60.33, which is similar to this one, so it means it is correct. And moving on to the recycle streams, which is stream 3 in this part here. Okay, now in stream 3, stream 3 is equals to stream 9 plus stream 1. Let us check here. Stream 3 is here, right? And stream 9 plus stream 1. Stream 9 here, going up here, right? And stream 1. So from here it goes down here, and it goes to the heat exchanger, as well as stream 1 that goes into the heat exchanger and comes out into stream 3 here. Okay, where was I? Okay, here. So we already know stream 9 is 60.33 as we calculated before, and also stream 1 is, well, only from the given one is 20. So we add that up, I got 80.33 mole. and then we go back to the previous one. String 4 is equals to string 3 plus string 2. Let's check here. String 4 is this one here. It equals to string 3, this one, and string 2. So string 3 comes with string 2 together, and it goes into this vector, being string 4. Okay, so as we know, string 3 is 80.33, and we also know string 2 is I'm sorry, I have a flu. 79 plus 21, and this is from the previous this one here. So we add them up, and I got 180.33 more. Okay, and moving on to the methanol pass conversion. So the methanol pass conversion is 95%. And how do I got 95%? I got it from 19 over 20 times 100%. And where does 19.20 comes from? Back again, this one here. Okay, then I move on to string 5. In string 5, there are many compositions. Let us see back here. String 5 is located here, this one here, string 5. So as you can see, string 5 is the output of this reactor, wherein this reactor has many inputs, such as string 3, string 2, and also this string 3 is from string 1, and also string 9, etc. So there are many compositions, and I managed to write it down here. So in string 5, there are CH3OH and O2, and CH2O and 2O H2O. So, and then I calculated the moles, and for CH3OH, we got 20 minus 19, which equals 1 mole. And then for O2, I got 21 plus 7.67 minus 9.5, which equals to 19.17 mole. And how do I got these numbers? This is from the previous calculations that I've did from here, and also from this one here. Yes. Then for the rest of it, it's just the same. And then I add them up, and we've got total mole is 189.84 moles for in string 5. Okay, now moving on to the temperature part, each temperature for each string. So from the given data from the problems, we only don't know the the temperatures for string 4. Sorry, focus. String 4 and string 6 and string 11. Now this is where it comes handy. This is string 11 here. String 11 here will be used in finding for the string 6. If I'm not mistaken, yeah, string 6. Okay, sorry. Okay, so starting off, as we know in the previous one here, string 4 is equals to 3, string 3 plus string 2, right? So we can apply the same thing here. This temperature string 4 equals to temperature string 2 plus temperature string 3. And temperature in string 2, as we know, in string 2, it is air. So there's O2 and N2, same as I mentioned in hold on, I forgot, and somewhere here I forgot. And yeah, and using the calculations that I got from this one, I forget the name, sorry. Then times the heat enthalpy or something, I forgot, but this is I got this from the given table from the problems. So I calculated the 21 times 0.2029, which is 0.609, and then for the N2 the same, 2.291, and then I add them all up, and then I got 2.9. And here stream 3 is CH3OH, and we know that from the given data, from the given table, the boiling point is 65 degrees Celsius, right? Okay, so since the boiling point is 65 degrees, this one, and in stream 3 here, it is past way over 65, so it is the state is different, the phase is different. So from the given table, from the problem, there is two I'm sorry, there's two CP, right? One is for the different states, each for different states, and here it passes the boiling point, so we're not using the liquid state, so I'm using the gas state, which is 0.043. Sorry, focus, there we go, 0.043. So as we know, CH3OH is 20 times 0.043 equals to 0.86, and the same thing for the O2 and the N2, but in this case is in the O2 and N2 in the recycle stream. Sorry. Okay, so it's the usual, this 7.67 and 52.67 is here. I got it from this calculation here. Where is it? There we go. Stream 8. Since stream 8 here, stream 8 is the recycle, right? It goes to recycle. Okay, and then from the same CP, calculate them, and then I got a total of 2.609. And then we calculate the energy balance for it, and I use 25 degrees Celsius as Tref. So T4 equals to the total of NTP delta T4, which equals to NTP2 T2 minus Tref plus NTP3 T3 minus Tref. And plugging in all the numbers, NTP2 we've got 2.9, and then the given information T2, I'm sorry, I'm a bit flu, we got 30 degrees Celsius, right? So we're done 30, and the Tref, as we mentioned, is 25, and NCP3, which is 2.609 minus T3 here is 200, right? 200, then 200 minus 25, the Tref here, then in total I got 471.06075. And back on the formula, T4 equals to NTP delta T4 over NTP total plus Tref. So we know that the NTP delta T4 is 471.075 over 2.9 and plus 2.609 plus the Tref, which is 25, which I got 110.51 degrees Celsius, which makes sense. Why does it make sense? Because as you can see here, we've got 200 here, and we've got we had 200 degrees Celsius here, and we have 30 degrees Celsius here. It is hot here, it comes off hot, 200 degrees Celsius, and it is exposed or kena angin 30 derajat, which makes it cooler, and it should be less than 200 degrees Celsius, and which it was 110.51 degrees Celsius. So it makes sense. Okay, moving on to T6. Okay, so we know the T4 already, right? And then moving on to T6. T6 here, T6 we need to know T11 first. So T11 equals to T1 plus T9. So where is this T11? T11 is here, equals to T1 plus T9. So as we know, T1 is then 30 degrees Celsius and T9 is 40 degrees Celsius. Okay, now as I did the same thing. T1 CH3OH, which is 20 times 0.24256, and why this time I use 0.256. I'm sorry for the noise out there, the neighbors. Why do I use this 0.256? Because the methanol here is in 30 degrees Celsius, which means it is in liquid state, different in this part where it is way past the boiling point, 65 degrees, which it passes the stream 200 degrees Celsius. In this case, I use the gas phase, but in this case I use the liquid state. So I calculated, I got 5.12, and then T9 I did the same, I got 1.749. Okay, and then I do the same as I did here. So after calculating all of that, I got T11 is 32.546 degrees Celsius. Then moving on to stream 6. So as we know from the previous one, where did I put it? I forgot. I'm sorry, I forgot where. So intinya stream 5 is equals to stream 6. Let us check here. Stream 5 is here, right? Stream 5 is here, is equals to stream 6, right? Yeah. If I'm mistaken, I already mentioned that part. So yeah. Okay. So we applied the same. We applied the same concept. So T6 equals to CH3OH, which is 1 times 0.043, which is equals to 0.043, and this is the compositions, right? And I did the same thing as the previous one. I got total of 5.749. Now this is where the T11 comes in handy. So T6 equals to T5 plus T11. Let us check. T6 equals to T5 plus T11, right? Okay, so I did the same thing as the previous one, and then I got the NTP delta T6 is 1563.82 kilojoule. Then we calculate the T6 as usual, plugging in all the numbers. I got 148.936 degrees Celsius. Let us check whether this makes sense or not. Let's say it's 148. T6 is 148, right? 6 is here, right? 148. It makes sense. Why? Because the input is 288 degrees Celsius coming off to the heat exchanger, and also 30 degrees Celsius of methanol coming into the heat exchanger as well. So logically it would not pass 288 degrees Celsius, which it did. 148.936 degrees Celsius. Okay, so next, the Q of the cooling system is the T6 minus T7, and then it's just doing the same thing. I'm sorry, I got flu. The known compositions, and I'm sorry, I need to take a tissue first. Okay, back again. I'm sorry for the inconvenience. Okay, T7 here, known compositions, and I did the same thing as the previous one as I did before. I got the total here and then calculated with the same method right here. And then I got 735.29 kilojoule for the Q of the cooling system, which is the T7. Okay, moving on to the heat release. I'm sorry, this is typo. It should be heat. Okay, heat released through the WHB. Okay, heat released through WHB. Okay, so how do we do this? It is by delta H Rx equals to delta HF CH2O plus H2O minus delta HF CH3OH plus half O2. And then since we already calculated from the previous calculations, we just plugging in all the numbers as well from the given table. I got minus 115.9 plus minus 285.8 minus 238.6 plus half O2, half O2, and I got the total is minus 163.1 kilojoule per mole. And this is the delta HRX, right? Now moving on to the Q of the WHP, which is delta HRX times the mole of CH3OH, which we know the delta HRX is minus 163.1, and then the mole is 19. This is from the previous calculations. Okay, then calculate those. I got 3098.9 kilojoule per hour, and the rate stream produced in WHB, you could use this formula, and stream equals to Q WHB divided by the delta H vapor, and we got 3098.9 divided by 40.6, and this delta H vapor here is from the given table from the problem, which I got 76.32 mole per hour. Okay, maybe that's it for my explanation for this assignment, the redo quiz. For the full to see more, refer back to the attachment that I sent. Thank you.